Okay, can everybody see this
Yeah.
and still hear
Yep.
me?
Yep.
Good. Okay. So we are going to talk about the truth about fish. And this is more in depth than the last fish program we did. And I'm actually featuring Sportfish of Ohio in the mix here because it's something that is wildly popular and it's something I know about and have been involved in since I was probably about 12 years old. I have had hundreds of opportunities to observe fish and aquatic wildlife. So the first thing, how are they able to float suspended in the water and dive and surface? And our picture here is of a very common fish and very popular with people of all ages, the bluegill, which is a sunfish for which there are about 28 different varieties or species, subspecies. Well, it starts here. All fish, freshwater fish anyway, have what is called a swim bladder. And that's that light green area you see in the middle. And depending on the species, there are two different ways that they might use the swim bladder to control their buoyancy. And they use it just like a submarine uses a water ballast tank internally to help it dive and surface. But fish do not use water as a ballast. They actually use either air or gas. Now, in the first instance, and this is a diagram of a largemouth bass, which is also a very, very popular game fish here. We have a set of gills that they all have, and that's on the left there, the red area that you see. And then what's circled is the esophagus. And they bring air into the esophagus that they process through the gills. And this is to add buoyancy. The esophagus then draws air into the swim bladder. And then to decrease the amount of air that's in the swim bladder to give them less buoyancy, the swim bladder actually siphons air off into the intestines where it is passed. So there, circled, there's the gill, the red. And then that kind of beige colored piece you see connecting the gill to the swim bladder, that's the esophagus. And then there's the intestines right below the esophagus, and there's a connection there where the excess air is siphoned off. So that's the first method, which is called esophageal. The second method is called vascular. And this is a close-up of what some fish's air bladders look like. And as you can see here, the swim bladder, which is it's just like a thin, fleshy balloon that is lined with veins. And the veins, when needed, the fish is able to somehow cause the veins to emit gas from the bloodstream into the swim bladder to inflate it as needed. And then to deflate, the veins are able to draw gas back into themselves to deflate it. And the swim bladder is very much like, as I know from being on dialysis, very much like a peritoneal wall in a human. The veins are able to draw in and pass fluids and gas, and this works in the same way if you're familiar with that. So, do fish actually breathe? And what we have here is a picture of a brown trout. And although they look very large here, they are not. Most of them are pretty small. If you are fishing for them and happen to catch one that's like 3/4 of a pound or more, you've caught a monster. Most of them are only about the size of a bluegill if you've seen those. And best place you might see people fishing for these is at Three Creeks, because the Three Creeks Creek is actually stocked with brown trout, and it's a very popular place to fish for those. But they're small but tasty. Hello, David Haig. How are you? Hello, David Haig. How are you doing? Hello, David.
Howdy.
Glad to have you with us. David is the owner and operator of Coyote Run Nature Preserve in Pickerington, for anybody that's heard of that. Okay, continuing on. Do they really breathe? Yes and no, and the same thing for us. What fish and we both do is actually filtering. You see on the diagram here, fish take water in through their mouth, and then they push it through the gills, and the gills have these frilled layers that are called gill filaments that take oxygen from the water and feed it into the blood vessels. And as you can see here, there are these tiny capillaries in the gills, and the water flows over them. And as it does, you've got a two-way motion of veins here, by which oxygen is taken into the blood. That bloodstream flows into the animal's vascular system, and then any blood that's in them that's depleted of oxygen goes out, and that actually empties into the water through those capillaries at the same time. So they are filtering water for oxygen. Now we, on the right, we actually do the same thing, except that we have lungs instead of gills. But again, the lungs are filled with capillaries, and they draw oxygen from the air. And what you have to keep in mind here, if you don't know, is that our air is not pure oxygen. Our air contains oxygen, it contains carbon dioxide, it contains water vapor, argon, a little bit of hydrogen. So when we breathe in, we're breathing all that stuff into our lungs, and the lungs only take from that the oxygen. And when we exhale, we're exhaling all that other stuff. So we are filtering just like fish are, except that we are filtering oxygen or filtering air, whereas they filter water. But the result is the same: oxygen taken into the bloodstream. Any questions on that? Okay, great. Now, what are all those fins for anyway? What's the purpose of all those? And the game fish that we see here is the muskellunge, sometimes called a muskie. They are our largest game fish. Um, Most easily found actually in Alum Creek Lake, for one. Um, they, when I say they are our largest game fish, they average between 36 and 44 pounds and can go up in excess of 50. Um, I have observed these being caught that were so large that they would only halfway fit into a landing net, a standard landing net, which will easily hold an 18-inch fish. So there are a couple of different versions of what fish have for gills. On the left and bottom for scaled fishes, they have what you see here. And on the left, we have a largemouth bass. On the bottom, we have a goby. And on the top, we have a spiny dorsal fin and a soft dorsal fin. The difference being the spiny dorsal fin spines are actually attached to the backbone, whereas the soft dorsal fins are not. And then we have at the back the caudal or tail fin. Underneath, we have the anal fin. And then moving forward, just past the gills, we have on the sides the pectoral fins, and on the bottom, a pair of what are called the pelvic fins, although fish do not have a pelvis. And that's pretty much the same thing as you see here for the goby, except for on top, they have what is actually defined as a first dorsal fin and a second dorsal fin. The difference between the second dorsal fin on them and the soft dorsal fin, which would be on a bass or a bluegill or a crappie, for example, is with the bass, the bluegill, the crappie, the very bottom edge of the fin is free, whereas as you see on this goby, it is actually attached to the skin. So it's not like a flap. Then we have something very different for all of our scaleless fish. And in this case, we've got a catfish, and our scaleless fish are catfish and trout. They have a dorsal fin, which sticks up way higher than on any of our other fishes. And it is very, very rigid, very needle-like. You can actually give yourself a very painful puncture wound or two from a dorsal fin on a catfish because they're very, very stiff and very sharp. Then at the back, instead of a dorsal fin, they have what is called an adipose fin. Kind of serves the same purpose as a soft dorsal fin, except it is smaller, doesn't have as many spines through it. Then they also have a caudal fin, which is more pointed shaped, whereas you see with the bass, it is lobed. It's like two lobes, and it's more like an actual tail on an airplane almost on the goby. And then below, the catfish and the trout have an anal fin, which is actually much longer than what it is on other fishes. And it comes up very close to the pelvic fin, which on these fish is more in the center of the body instead of being uh, close to the gills. And then right behind the gills, you have the pectoral fin. Okay, so what do these all do? They do all have a purpose. And I have a good diagram for that. For every fish, the dorsal fin and the anal fin below are for balance and staying upright. If you think about this as three-dimensional, it's so that they're not tilted in the water. The caudal fin or tail fin produces forward movement. And on the bottom there, the pelvic fin, which there's always a pair of, are used for steering left to right. And the pectoral fins are also used for steering. The way those two work in concert, the pelvic fins, if they're used alone, that's like for like negotiating a wide turn. If they want to negotiate a sharp turn, they use the pelvic and the pectoral fins at the same time. It's kind of like, if you remember back in the late 80s, some of the automobile companies had come out with these expensive sports cars that had normal front wheel steering, and they also had a limited rear wheel steering, which allowed you to turn more sharply quicker. And this is kind of the same thing. The pectoral fins also have a second use, which is they can pull those out at a 90-degree angle from the body, up to a 90-degree angle, to help them in slowing and stopping from forward motion. So those have a second use. So that's what they are all for. Anybody have any questions on that? Okay, great. Next, we are going to talk about the most varied and intricate part of fish's lives, which is breeding and rearing young or not. As you will see in the two pictures here are crappies, which are another good, very popular game fish here. On the top is the white crappie, and on the bottom is what we have the most widespread, which is the black crappie. Incidentally, the black crappies taste the best. So when it comes to breeding, there are a few different types of breeding. And I have some examples here. On the left, what you see is called a bubble spawn. This happens to be from yellow perch. And what they do is they lay this thinly veiled sac of thousands of eggs, and they drop it above weeds or substrate, and it attaches itself. And they leave it like that. They go away and leave it like that to its own devices. On the and we'll talk in detail about this on the totally irresponsible side of things. Next to that, in the middle, we have what is called scatter spawn. And this is what walleye do, and some other fishes we'll see. They just let loose with thousands and thousands of eggs in the water, pretty much anywhere, and then they go away and forget about it. And we'll see what effect that has. On the extreme opposite end of that, on the right here, upper, this is a largemouth bass, and they do what is called substrate nesting. They actually create a nest in the substrate at the bottom of a lake or stream. They prepare it, they lay their eggs, and until the eggs have hatched, the mother stays right there on that nest with them. She doesn't leave. The father brings food for the mother, and he also chases away predators. And in addition, while they are in this condition, anything that happens to fall into the nest or gets dragged through the nest or swims into the nest, she removes it or chases it out. But usually she physically removes whatever it is. Now, on the lower left, catfish, and in this case, a channel catfish, as you see here, they substrate nest also, but theirs is a little different because they do not create their nest just in the bottom of the substrate of a stream or a lake. They go along the bank and they find substrate along the bank that is weedy or incorporates sticks down branches in the water, undercuts in the bank where there are roots sticking out, and that is where they make their nest. But they do the same thing. The female attends to the nest until the eggs hatch. And just for interest, overlaying that, that is what channel catfish eggs look like. They deposit them in kind of a string like you see there, and it just has a sticky substance on it that attaches to the plant matter or detritus wherever they have created their nest. Then on the far right, our fifth type, this is called weedy substrate slash bubble. And in this instance, it's a carp. And what these fish do is it's kind of like you saw with the perch, the bubbly looking encasing of eggs, but they lay it right into mats of weeds, and it attaches itself to the weeds. And you see a close up here of a little bit of weedy material with the eggs attached to it on the right here. So that is the 5 different types, and we will now talk about what they are by species. And our photo here is of 3 alligator gar. They are also a very large fish found in the larger lakes and most famously in the Ohio River, where they get to be huge. They get to be the size of sturgeons, and they have a very wicked mouthful of sharp teeth. They have been put into some areas to control other fish populations. So this is all of our game fish species in Ohio and when and how they spawn. The first is for perch. They bubble spawn, and it's in early spring. Then next, we have our substrate nesters. We have chub, which are really more of a bait fish, larger bait fish, but they spawn from May to June. They substrate nest. Smallmouth bass, substrate nest, and they do that in May. Largemouth bass, substrate nest from late May to early June. And the big difference between the smallmouth and the largemouth is smallmouth bass, their habitat is streams or lakes, areas of them that have gravelly bottoms. They will only be in gravelly bottoms, whereas largemouth bass don't really care what's on the bottom. They will be in areas where you have more of a more of like a muddy, if you will, substrate, strewn with rocks. They like a lot of areas that have down tree limbs, tree trunks, things like that. They like those things for cover. Next in the substrate nesters, as I mentioned, was catfish, and they spawn from late spring through early summer. And then the final substrate nesters are the sunfishes, bluegill, sunfish, pumpkin seeds, warmouth, all the various um, species of those, and they spawn, build their nests in May. Then our one substrate, weedy substrate or weedy bubble substrate species is the carp, and they spawn May to June. Then we have our scatter spawners, and it's interesting that two of the scatter spawners, the walleye and the muskies, are the most fierce hunters. They're the ones with the big mouths full of teeth, but they're the ones that just lay the eggs, and they dump and run. So walleye is spring to early summer. Muskies May to June, and then brown trout are also scatter spawners, and they go early spring, late fall. And then finally, pike, northern pike, they spawn from February to May, and it's not quite scatter spawning, not quite bubble spawning, because they will go into areas, shallow areas, to spawn, kind of like we see with salmon, and they lay their eggs, which attach to rocky or gravelly bottoms, and then they actually go away after that. And one thing I will mention about this is that for the fish like the trout, which spawn in early spring or late fall, the walleye that spawn in spring, they spawn at those times because that is when crustaceous predators, namely crayfish, crawdads, they are not active. The brown trout, for example, know that early spring, late fall, the crayfish are not active and are not going to go after their eggs. And this also relates to aquatic turtles, which will also go after the eggs. So that is something a little different that they do. Now, about walleye, you may have heard about how we have these periods of absolutely humongous walleye hatches. And if you see on the right here, 2019, Lake Erie, there were 50 million adult walleye. That was the population. For 2020, they predicted it was going to be 116 million, which did end up happening. 2021, they predicted 151 million, which panned out. And Now it takes a couple years for this to catch up. For 2023, they think it's going to be 3 times what it was in 2021. So you're talking about 4 million. How does this happen? And there are some peculiar things about this. A female walleye lays up to 500,000 eggs each year during their spawning season. 500,000 each. So you might see where this is leading. Do the math. In 2019, again, we had 50 million adults in Lake Erie. If half of them were females, that's 25 million. And if each of those 25 million laid 500,000 eggs, that's 12.5 trillion total eggs. Now, to jump a year, 2020, there were estimated 161 million walleye. 1,100 million of those would have been new adults. And for there to have been that population, that means that from 2018, the egg survival rate would have only been 0.00129%, which is incredibly small, right? Now, if you drop down to the next box, again, we had the 161 million adults in 2020 in Lake Erie. And if you divide that in two, that was 80,500,000 females, each laying 500,000 eggs, which means we had 40.25 trillion eggs coming from them. But now for the 2023 estimate of 453 million adults, with 500,000 eggs being laid by each of the females, that means only out of those 200 million some females, only 906 of those, or excuse me, 40 trillion females, only 960 of those had full egg survival. So with egg survival that low, how are we getting these populations of 100 million or more? And before we jump to that, I'll just mention on the right, that top photo is a layer of scattered walleye eggs. In the middle, we've got a picture of a walleye face close up, and you can see they have some teeth. And I'll tell you, yeah, they're sharp and they can cut you up pretty good. And then on the bottom is a close-up of walleye eggs that are just a few weeks old. So getting back to these numbers, how do we have such high walleye populations when there's such low egg survival rate? That is almost strictly because of predation. Predation from these 6 species. Now, the first one on the upper left there, that's the yellow perch, which is a very sought after game fish. And the yellow perch, they slurp up walleye eggs when they find them like they're Skittles. It has changed a little bit in the last few years because the yellow perch mainly were in the eastern part of Lake Erie, but for reasons that researchers don't know why, there were some very, very large hatches in the western bay of Lake Erie of something called sand fleas. And the Yellow perch love those also, and they somehow figured this out. So they'll be in the eastern part of the lake and they'll be eating up walleye eggs. And as soon as those sand fleas are hatching in the Western Bay, they all move over to the Northwestern Bay and they feed there till the sand flea eggs are almost all gone. Then they move back to the east to see if there's any walleye eggs left. Now, top middle, this one is also eats tons and tons of walleye eggs. This is the round goby, and they probably eat more of them per pound of fish than any of the others. Next to that, we have the silvery looking fish is the white bass. They eat a lot of walleye eggs. Bottom left, this is the freshwater drum, or what a lot of people refer to as a sheep head or sheep's head. They eat a lot of them also. They eat the sand fleas, but they eat an awful lot of walleye eggs when they find them also. Then in the center, the channel catfish, they eat a lot of walleye eggs. And on the right, which is the shovelhead or flathead catfish, they eat a lot of walleye eggs also. And all of these fish are, well, with the exception of the catfish, all of these fish are highly populous in Lake Erie. So they really do a lot of damage to that egg population. But even though they do, there are still so many eggs that survive. I mean, it's you almost can't imagine it. A couple of years ago, I was fishing in late spring in Lake Erie with my brother-in-law, and we were trolling around a 3 mile square area that was about a mile and a half off the shore of Cedar Point. And the entire time that we were in that 3 mile square area, there was this black band at the top of the fish finder that was a little fuzzy and thick. That black band was one big solid mass near the surface of walleye eggs, 3 miles square. And that was just one area. If that gives you some idea how many eggs, and these things are only about the fourth the size of a pea when they're laid. So it's just mind-boggling. And this one right here in the middle, I want to mention the goby, the round goby. They are an invasive. And the only good thing about this is the catfish eat them when they find them. Walleye eat them when they find them. Larger perch, yellow perch will eat them. But it's usually the smaller ones because the perch's mouths aren't that big, and it's usually the largest of the perch that eat them. And usually the largest of a perch is not going to be more than just under a half a pound. So while it happens, it doesn't happen that much. It's mainly the catfish and the walleye that eat them. But there's millions also, not hundreds of millions, but there's millions of these gobies in the lake. And ODNR is still searching for a way to get rid of these things. And it's mainly because of that, the destruction they do to the walleye egg population. And here I just wanted to show you, these are some close-up pictures of various fish eggs in different stages of development. On the left there, upper left, that is newly laid yellow perch eggs. Upper center, that is walleye eggs that are, I don't know, 3 to 5 weeks old, maybe. On the upper right there, that is channel cat eggs that are, again, maybe a few weeks old. Bottom center, those are a cluster of carp eggs, fairly newly hatched. And then on the left, this is an advanced stage of a cluster of walleye eggs. And there you can see they are very much taking the shape of a fish. The eyes are very well defined. They're still translucent, but you can see they're really beginning to take shape as what we would recognize as fish. So now this is just going to walk you through some of my photos that have to do with spawning. On the right, that dark area you see in sort of the lower middle, and these were taken at Homestead Park. Just believe it or not, with my iPhone, that the two dark spots that you see, the one in the lower middle and the one near the bottom, those are nests that have been started by bluegill. Again, they substrate nest, but the difference between them and some of the other fishes is when there is moss or aquatic plants growing in the substrate, they like to leave that and just make the hole around it. So it's a little bit of a camouflage. And then in the photo on the left, you can see this is a completed nest. And in the middle of that nest, which is right in the center of the photo, there is Mama Bluegill sitting on her nest. Now, the next thing I will show you about this, if you see all those little black marks up above on that photo, those little black, almost look like little stripes, those are young bluegill that were hatched the year before. They're what's called yearling bluegills. They're very small, bigger than minnows, but smaller than adult fish. They're waiting around that nest there to see if they can swoop in and get a meal of some eggs. That's what they do until a male comes along that belongs to the nest and chases them away. It's very interesting to watch. Now here on the left, this is a largemouth bass, and they do a little bit differently. They like a gravelly, although they don't live in gravelly bottomed areas, they like a gravelly bottom or rocky bottom for their nest. And they spend a long time cleaning everything out of that area. They use their mouths to remove plant detritus, and to remove plants, they will actually use their mouth to pull moss and stuff up out of the substrate and move it away, so that they've got just this gravelly or rocky circle. And when they can, they like to incorporate a rock or a piece of tree limb or something that they're unable to move as some sort of cover for them. And on the right here where my cursor is, you see a largemouth bass male, and I'll tell you why you're seeing what you're seeing. That's Daddy. And below him, that darker area, that's that same nest that I showed you on the left. And Daddy is chasing an adult bluegill away from that nest, because same thing, that adult bluegill wants to, when When it thinks the female's back's turned, swoop in there and get a mouthful of eggs. Daddy makes sure that they all stay away. And although it's probably not fair play, fishermen have discovered that anything, like I said, that falls or drops into a bass nest or gets dragged into a bass nest, the female will pick it up and remove it. Fishermen now take advantage of this, and it's legal. Unfortunately, fishermen will get a lure that looks like it's like a soft rubber worm, a small one, and they will look for nests like this, and they will intentionally cast and drop that lure to the far side of the nest, and then they'll slowly drag it through the nest, knowing that the female is going to pick it up. And well, when she picks it up, she gets hooked, and she gets caught, and most of the time ends up on somebody's dinner plate. So now the final thing, there's a lot of misconception about this. People say catfish and carp not good to eat because all they do is eat crap off the bottom. They think that they literally live on eating the feces of other aquatic animals, and that's their diet. Well, that is absolutely false. Catfish are strictly carnivores. They are meat eaters. Now, sometimes they will eat a dead fish or a part of a dead fish, but usually they want live meals. They mainly go after minnows, small fish, sometimes scud, crayfish. They want live meals. Carp, on the other hand, on the right here, they are omnivores, although they are mostly vegetarian. They greatly prefer to eat aquatic plants. They will go to eating live meals of meat, minnows and stuff like that, if their supply of vegetation has been completely depleted. Before they think about moving on to another area, they will turn to eating minnows and other small fish, sometimes even dead fish, but they're mainly vegetarian, although they are considered omnivores. Any questions on anything we've covered? All right, great. So one last thing I will leave you with before we go to comments, questions, discussion. This fish that you're seeing here, this will most likely be the only way you will see this fish. This is called a Mad Tom catfish. The only place they ever existed in the world is in Big Darby Creek. And the interesting thing is they are on the ODNR's endangered list, even though the last time one was spotted was 1953. I'm almost 65 years old. These things have not been spotted since 3 years before I was born, but they're not on the extinct list for some reason. They're on the endangered list, and I do not know why that is. And anytime you see any literature including these, there's a statement from ODNR saying that if you see one of these or catch one of these, release it and notify the ODNR immediately through their sighting form of where and when and the particulars and all that. It's not a big fish. It actually, in real size, is probably about 3/4 of the size of what you see on the photo here. Okay, so that's it for the presentation. I'm gonna stop share here. Anybody have any questions or comments or anything they'd like to talk about related to this? Well, I know everybody's still there.
I'm here, just quiet.
I will mention one thing since David is on here. And we've had some connections in the past. As I mentioned, uh, David owns and operates with his wife the um, Coyote Run Wildlife Preserve, which 300 acres of it, I believe, correct me if I'm wrong, David, 300 acres of it are considered by the ODNR as state wildlife preserve, and the rest of it is basically private. Um, there are almost, because it's a nature preserve and this is David's way, it is almost the entirety of it has nothing in the way of improvements or amenities. And again, correct me if I'm wrong, David, the entire nature preserve is something like 3,000 acres, if I remember right. Uh, it's a large place, very easy to get lost in. And I have been absolutely thrilled with what David is doing, because he and his mother have set up a foundation to cover this. His mission, his vision is to return this property to what it was before Ohio was settled, and for it to remain that way for 500 years. And the foundation has enough funds to support one person for maintenance and one person for programming for the next 500 years. And the thing that really struck me when I first visited was David told me that people tell him that they think this is a wonderful thing he's doing for the public and so on. And he just replies, I'm not doing this for the public. And what he means is he is doing this only for the benefit of the wildlife that is in that area. He's only doing it for the benefit and the longevity of the creatures and the plant species and so on that are there, which, not to embarrass David, but I think that is the most awesome and incredibly righteous thing that I have ever heard of anyone doing in terms of wildlife work, in terms of conservation. So where I'm heading at with this, on David's property, there is an area that has about 40 some, it's a wetland area that has about 40 some vernal pools in it. And there have been spotted about 130 different bird species there. And what I would like to do is get some people together, and you are all invited. I want to get some people together to go out there in April when we're in the middle of um, migratory season, and just go out there for a morning or an afternoon and do a bird count for David in that area and see what we can come up with for him. It's data that he really needs. Um, he relies for a lot of this type of support on volunteer work from people and from things that ODNR and Fish and Wildlife do for him. So I would like to get this organized and see it happen in April. So if anybody is interested about this, and I will be sending out an email about it, let me know, and I will definitely get you included, and I will let people know what we're going to do for a date as soon as possible.
Don, another
Yeah,
thought about that is doing a breeding bird survey in June, a
in
little
June.
later
Yeah,
on. Yeah, because migratory will tell you a bit to see what's there
right.
and look at the different habitats. But it would probably be even more important to study the habitat and look at breeding bird surveys too.
Well, I'm absolutely open to doing both.
Yeah. I can't help,
Yeah.
unfortunately, in April or May, but I can help in June if you wanted to do a breeding bird
That's
survey. We can look at
yeah.
grassland.
I think that's a great idea, and I'm sure David would be receptive to that also.
Yeah, and just like we do at Glacier and other places, do the grassland surveys. We could actually even see about getting markers to put out, so you survey the same spots every year, and at first maybe
Okay.
identify those spots.
Yeah. Beside that property, besides that wetland area, it's got a little bit of everything. It's got grassland, it's got pioneer growth, it's got some old growth forest. It's actually even got some wetlands in the old growth forest area. It's got a little bit of everything.
Well, the
So
old growth
it's a good
forest would be,
opportunity.
well, that would be super important for a breeding bird survey because that's what some species that are very specific would look for. Is
Right.
there, in the wetlands you mentioned, are there like larger ponds or lakes on there for wetland, for shorebirds, water birds and stuff?
Um, David, are you there to answer that?
Can you hear me?
Yep.
Yeah.
Okay. No, the largest pond is about 6 acres. Most of the rest of them are just vernal pools and small wetlands.
Okay, it's good to know. Are there in the old growth forests, are there pine areas, hardwoods, or what do you have there?
Well, I would consider older growth, probably maybe 150 years since it's been last logged.
Okay,
And
good.
it's mostly beech maple and oak
Yeah,
mixed
mature
in
forest.
there.
Great. Because I was thinking about owl habitat, if there are any pine areas to go assess in the wintertime for some of the winter owl migrants, like the long-eared owls. And then in field areas, if you have short-eared owls and things, I know people that would love to look for them.
Great. Yeah, that'd be awesome. Yeah, I would love to give David whatever help we can to that end, and for Christy and anybody else that might be an OCVN by then, that because of the status of Coyote Run, that is something that you could use as credit towards your volunteer hours. Not that that's the main reason for doing it, but that's a nice little side benefit of it.
Well, I'm on some
So,
private birding groups on Discord and Telegram and stuff. And
uh-huh.
once we sort of get things together and look at it, I can call out for volunteers on that. And these
That'd
are
be
people who
great.
are professors at
That'd be
OSU. They're the
that
people who
that
run like eBird lists for Ohio and stuff.
yeah, that'd be awesome. And one nice thing about this too, that helps, is one of the very few improvements is at that wetland area. David has built a bird blind that is up on some stilts, like to the height of a second story of a building, and on two or three sides, I think it is. It's got big plexiglass windows, and it's got seating and so on. So that's a good place to get up in the air a bit to get a different view than you would from the ground. So yeah, definitely something I'm looking forward to putting together. And it's 9:24. Unless anybody has anything else, one thing I will tell you, and I'm not going to let the cat out of the bag, but please tune in next week because I have something very special to unveil for everybody, and it's a project I've been working on for quite a while, and it's going to be finished in the next day or two. And I think it's going to be very interesting for everybody to see this. So count on next Thursday evening.